Talking of a simple pendulum is a device which consists of a heavy point mass called as bob connected to a rigid support by a thin, inextensible, and a weightless string that is free to oscillate about this rigid support. As it goes from mean position to extreme position, it traverses an angle. When it traverses an angle of theta, that means we know that from the study it is an angular simple harmonic oscillator. Now we have to calculate what is the equation of its time period. From the recent lectures, we know that time period is equal to 2 pi root of inertia factor by the spring factor. In this case, we have to look what is the inertia factor in this case and what is the spring factor. We have to calculate those. We will get the equation for the time period. For that, we know that the weight of the bob is vertically downwards. As the weight of the bob is vertically downwards, resolving this in horizontal and vertical components, its horizontal component is mg cos of theta. That mg cos of theta balances the tension in the string, and its vertical component is mg sin theta. This mg sin theta acts as a restoring force that brings it back towards its mean position. When we talk of angular SHM, we talk of torque, and that torque is equal to F into L, as the angle is 90 degrees. Now, here the restoring force F is equal to minus mg sine of theta. So, the restoring torque equals to minus mg L sine of theta. If we take the angle as small, we can take sine theta equal to theta. So torque comes out to be m minus mgl of theta. We also know that torque is directly proportional to theta. More is the angular displacement, more is the torque. Less is the angular displacement, less is the torque. We can introduce a constant of proportionality, that is k. So T is equal to k of theta. The restoring torque opposes this angular displacement. So torque is equal to minus k of theta. Let this be equation 1 and let this be equation 2. Equating those two equations, we have that minus k theta is equal to minus mgl into theta. Minus and minus goes, theta and theta goes. So our spring factor comes out to be mg and l. Going for the inertia factor, the inertia factor equals to moment of inertia, and the moment of inertia of this bob connected to this rigid support by L length L is equal to ml square. We know that time period is equal to 2 pi root of inertia factor by spring factor. So T comes out to be 2 pi root of ml square divided by mg into L. M and M goes, 1 L and L goes. So the time period of simple pendulum comes out to be 2 pi root of L by G, where L is the length of the string and G is the value of acceleration due to gravity. That means it doesn't depend upon the mass of the bob. So a larger body and a smaller body can have the same time period if they are connected by same length of the string and at the same location. At the same location, the value of G will be the same. Thanks.